Hi, this is Ida Quita, and welcome to Episode 3 of the walkthrough of the HackerRank C language track. In this episode, we'll be going through the Conditional Statement Challenge. If you haven't viewed the earlier episodes, go do that now. As usual, I'll point out tips, pieces of C++ information, and show errors you might encounter while I solve the challenge. I'll show what my process is, but you really need to do this yourself to get value out of the challenge. Be sure and get a HackerRank account of your own so you can. Please note that the website and all content from HackerRank is their copyright material, which I'm using for educational, fair use purposes. Well, let's get going on conditional statements. Conditional statements are where programming gets really interesting. In the prior programs we've written, the statements can only run in the order that we wrote them down. They couldn't change their order, and they couldn't even choose whether they executed or not. With a condition, we allow the program to make a choice to run a set of statements or not. We do so with an if statement. It's of this form. There's an if, there's a condition, something that's true or false, and a block of statements. In C++, it's legal to have only a single statement and no curly braces, but that can lead to some subtle errors. So it's considered good practice to always enclose the statements following a condition in curly braces. So if the condition is true, we'll execute this block of statements, and if not, we won't. Well, in this next extension, optionally we can add an else, which means if the condition is satisfied or true, then we'll execute this first block. Otherwise, we'll execute the second block. The second block won't be executed if the condition is true, and the first block won't be executed if the condition is false. And finally, what if I had a lot of questions to ask? Well, there's the else if. It means I can continue to ask a series of questions if the first one or if all the prior ones don't pass. A first condition, we would execute this block. Otherwise, we'll ask ourselves this next question, and so on through the last else if. And finally, and optionally, you don't have to have an else, if none of the conditions are satisfied, then the code in the optional else block is executed. Well, let's look at what a condition is in a little more detail. First, a condition is just an expression or even a single variable, and the if looks at the value. If the value is non-zero, then the condition is satisfied or considered true. There's a common error that we'll see in the walkthrough. I'll come back to that in a second. Conditions also represent logical values, and we didn't mention it in the data types episode, but there's actually a data type to store that, bool, B-O-O-L, which is short for Boolean, having to do with truth and falsity. It only stores the values true and false, which in C++ are written exactly as you see them there. And what would you store there? Well, for example, the outcome of a comparison operation. And here are the comparison operations you have available to you. I won't read the list to you, except to point out one little thing. The exclamation point is sometimes called bang. You'll hear me say that. And it's also logically thought of as a not. So that's why that's not equal. But those are the choices, and that gives you about everything you could want. And finally, if we want to combine logical outcomes of comparisons or variables, we can do logical operations, and, or, and not. Imagine you have a set of preferences which we'll store in want pizza, want delivery, and anything but pizza. Consider the difference between I want pizza and I want delivery, or I want pizza or I want delivery. Well, in the first case, you're only going to be able to order from restaurants that deliver pizza. In the second case, you could either go out for pizza or you could order from restaurants that deliver anything, including pizza. The last one is not. Well, if I want pizza, the logical not or opposite of that is anything but pizza. So if want pizza is true, then anything but pizza would be false. And if want pizza is false, well then anything but pizza is true. Well, let's go put this together and answer the challenge. Well, what is the challenge? We're going to be given a number between 1 and 9 inclusive, and we're going to translate that into the English word. Also, we're going to, if we get a value greater than 9, output greater than 9. As before, let's put that into our code. So I've copied that. The input is a single integer. It's between 1 and a billion. As we discussed in the data types episode, that will fit within an int, as an int goes between positive and negative 2 billion, roughly. And you can see the example. We're going to see a 5 and output 5. All right. Let's go ahead and insert those comments as a bit of documentation. So if, notice that the fancy stuff didn't translate. Now I've written it this way. This is not valid C++, but it looks like the way you would see this in your algebra textbook. So there's our documentation. Translates a digit into English. Okay, that's what we're supposed to do. Well, the first thing I want to note is there are a ton of includes here, and we don't need any of them. And it's really quite a bad practice to include code you aren't going to use. It's just code that can go wrong, because if you're not using it, you're not testing it. Also note that we're using namespace stud again, just to save ourselves typing. But again, in a large program, you wouldn't want to do this generally. So how are we going to solve this? Well, we don't need to worry about the input. That's been done for us. But the first thing I'm going to do isn't in the task definition. Note that it didn't say what to do if you get a value that is less than 1. Well, there are lots of security problems that happen when we don't check the inputs. Oh, they promise they'll never send us a number less than 1, but it's always good to cover all possibilities. So I'm going to ask the first condition, is n less than 1? Well, if it is, I'm going to assume something went wrong, and I'm going to let the operating system know. Remember how we do that? Is to return something that isn't 0. And we can put out a meaningful message to standard error. That's like standard output, only it's for error messages, and it can be captured separately from standard output. We're going to say the input was out of range. Less than 1, because that's useful information to know. Well, let's see if we can make the test fail intentionally. Well, 0 is less than 1, and when we run the code, we're going to see a compiler error unless I add that semicolon. Always good to check. And sure enough, it says we had a runtime error. Well, of course we did. We reported that error. There was nothing to standard output. We didn't put anything to standard output. But to standard error, here's our error message. Okay, we've handled that first case. What's the next case we might want to try? Well, let's try translating the digit 1. Well, how will we do that? Well, if n is equal to 1, then we're going to simply echo to cout 1. The other case, when we're all done with the cases in between, would be and we'll just copy that from the requirement so we get the text exactly right. Is greater than 9. Let's test this on 1 and 10. When you're developing code, it's sometimes a good idea to test small cases to make sure you have the right approach. Well, 1 works. 10 works. And notice, by the way, we are doing something specific for every input, for n less than 1, for n equal to 1, and for every other n. Well, that's good because you never want to have an unhandled input case. Well, to save you watching me type, I have, ahead of time, typed up all the rest of the cases because all the rest of the cases just look like the one case. And we'll just copy those in. We have if n equals 1, output 1, if n equals 2, output 2, and so forth, all the way down to n equals 9. Well, let's now try this against the basic set of cases. Well, there's a typo. Let's fix that. Well, what's the problem here? Well, my output was 5th, and the program expected to see 5. The test program expected to see 5. Well, that's correct. 5th is not the correct name for the digit 5. Let's try running these cases. Okay, we pass all 3 of the basic cases. 5, 8, 44. Well, let's try running it against all the cases. Oh, test case 9 fails. Let's see what happened. In HackerRank, you can download the answers. Sometimes they'll charge you what are called hackos, but you earn these in website credits simply by solving problems. Well, that was for input test case 7. Well, we know what we should have seen from 7, and apparently we didn't. Let's go see what's wrong with the 7 case. Well, 4, 5, 6. 6? Oh dear. I've tested the same condition twice. It turns out that if I test for the same condition twice, I'll catch the first one and ignore the second one. And notice I never test for 7. So 7 would have fallen all the way through to greater than 9, which is, I'm sure, what we saw. Now that we've fixed that, the simple set works. The full set drumroll works. Okay. There we are. We've completed this challenge. We have this fairly complicated if tree, but it solves a problem. This kind of complicated if tree is subject to a number of errors. You can have cut and paste errors. As you saw, 6 and 7 were wrong. Well, 7 was wrong because I copied the 6 case, and when I changed it to 7, I didn't change it completely. Making lots of very similar entries in your code is a good way to make mistakes, and we made one. Well, what else could go wrong? What if I, instead of putting 2 equal signs, put in 1 equal sign? What might happen? Oh dear, all the test cases failed. This one thinks 1, this one thinks it's 1, and this one thinks it's 1. Well, how come? Remember I said that it's a common error when you use an assignment instead of a double equal. The value of n equals 1 is the value I'm assigning to n. And remember, any non-zero value is considered true. That means this will always be true. The only time that we won't get to this case is if we had had an invalid input. There are some people, for that reason, that like to reverse the order of comparisons when there is a constant involved. Because if I make the same mistake here and put in a single equal sign, I'll get a compile error because it'll say, well, the left-hand side of an assignment operator can't be a constant. And that's nice to catch that kind of error as a compile error as opposed to a runtime error. However, whenever you're writing code, do what the rest of the code in the project looks like. If all of your project has variables on the left, constants on the right, then write your code that way. Some people think it's more readable. Again, be compatible. And be aware that that's an issue that can arise. Well, we've fixed that. What else could have happened perhaps at compile time? Well, what if I had forgotten this closing brace? What would that error look like? It said, well, I expected to see a closing brace before else. Well, that's a nice obvious one, and here it is. It stands out right there. It says, oops, I have an opening brace, but I don't have a closing brace. What if I were to forget the opening brace? Well, it looks like I have a whole bunch of errors. And the reality is that what happened is, by forgetting the opening brace, look at the highlight of the green. And lots of editors will do this for you. When I click a brace, it shows its matching brace in highlight. I ended the function. And now all of this code is living outside of a function, and the compiler goes, no, 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 no. You can't do that. So all these errors are really just this one error. Well, if I say, well, I remember that Itaquita told me that I didn't need to have a brace, I'll just do without the brace. Let's see what happens now. We're going to compile correctly, but all of our tests will be wrong. Actually, we won't even compile correctly, because you can't have an else when there isn't an if. Well, I'll say that's strange. I'll just get rid of my else. And now what happens? Well, I compile correctly, but everything is wrong. I don't output any code, and I have a runtime error. Well, I only have a runtime error if I returned a non-zero value. And the only time I do is here, which we thought was controlled by that condition. Remember I said that if you don't have curly braces, only the one statement is associated with the condition. That means that this bit of indented code that usually shows that it is subject to a condition, and in Python or other languages would absolutely be subject to that condition, isn't. This return one is always running. And that's why you always want to include the code following your condition in a curly brace. Notice that by listening to compiler, I kind of led myself astray. I went from what was a syntax error into a logical error because I didn't really think about why was it telling me that I had an extra else lying about. Well, I did because I was no longer in my if, because I'd had two statements following the condition. All right, let's delete one more and see what happens. Again, we have that problem where we have introduced a brace that matches the wrong block. We have a brace mismatch, and so we have this pile of errors. And I will show you that you can live without a brace if you have a single statement. And sure enough, the simple test cases pass. But as we saw, that's a recipe for potential disaster. So a best practice is to simply always have curly braces. Well, that solves this problem. We've passed this challenge. And at this point, feel free to tune out, and I'll see you next episode. But wait, there's more. I have a bonus solution for you. You'll look at this pile of ifs and else ifs, and you say, well, this can't be the way anybody would really do this, or coding would be very tedious. Well, that's absolutely right. Nobody would write it this way unless what you had to do in each case was very specific and not easily generalizable. The other way to correlate a number with a piece of data is using an array or a vector. You'll remember we deleted a whole bunch of includes, one of which was vector. And a vector is a data type that stores more than one data element that is indexed by an integer value. That means using a number, you can select which entry you want. So the way that we would do this, and we'll have a whole episode on arrays and vectors coming up, is to say I want a vector of strings. This is a template. Don't worry too much about the declaration here. We'll come back to it later. And we're going to call it names. And we need to give it some initial values. Well, to save you watching me type badly, I typed that earlier for us. And I'm going to say the names are 1, 2, 3, 4, 5, 6, 7, 8, 9, and greater than 9. The thing to be, and so let's go ahead and try it. We're going to say name. To output, we're going to simply say name, and then of the selector is the square bracket of n. Let's see what happens when I run that. Ah, there's a good typo. Include, not include. Again, always look at the first error. It usually is the one that's triggering all the ones down the page. And the missing terminator. Arnold, where are you when we need you? And we fail. Why? When I got an input of 6, it got me 5. When I put an input of 8, it got me 9. And when I put in 44, we got an output of, well, that's just the wrong answer, greater than 9. Well, why did I get that? Well, the secret is how vectors and arrays are indexed. They are zero-based. That means the first entry is square bracket 0. So 1 correlates to index of 0, 2 correlates to index of 1, and so on all the way up to greater than 9, which correlates to index 9. Well, notice the rule, that the word is aligned with a number 1 less than it. Well, then I'll simply input n minus 1 as the index, so name of 1 less than the digit I was given. Notice that I'll never get a number less than 0 because I tested for that. Good thing. Let's try running this code. Well, test case, the last test case was not happy, 44. Well, let's really make it unhappy. And give it an input of 100,000. Now we got a segmentation fault. We got a segmentation fault, which means we touched memory we weren't allowed to. Well, why is that? Let's take a look at this. I said I want to look at name entry 99,999. Well, how many entries do I have? Well, I only have 10. 0 through 9 is 10. So how can I fix that? Well, we know that the answer for 10 is going to be correct. So we can fix that with one conditional check. If n is greater than 9, what in the world did it do? It's a funny editor. then we'll simply treat all numbers greater than 9 as 10. Let's see if it likes 100,000 any better, or whatever number that I typed. And sure enough, 100,000 is greater than 9, and I didn't get an ugly segmentation fault. So now with two if statements and a predefined table of answers, I can now answer this problem with many fewer lines of code and many fewer places for bugs to live. This is the way that you would most likely see this done in a real program. And I wanted to show you that coding isn't just tedium, that there are good tools available. We'll come back to arrays later in episode 5, I guess. Anyway, there's your bonus content. Congratulations, you stuck around. I hope you found this useful and fun, and I hope to see you in episode 4 when we start going in circles with the for loop. See ya.